Okay, so today's agenda will go through, of course, electrochemistry is a very huge topic, right? So we can't possibly go through everything. So I picked out the most important concepts that you should take note of, which is electrolysis of aqueous solutions, okay, electroplating and purification of metals, okay, and then your simple cells. Okay, so these three concepts, hopefully by the end of today's session, you will grasp fully these three concepts. Okay, then I ask you guys to try the structured questions or the MCQs at home, the questions at home, so that as I go through today, you can see what you're missing out on. Okay, then whenever I'm going through, if you have a question, you can just type it out in the in-call messages. Okay, so your in-call messages should be at the bottom right if you're using a computer. Okay, then at the end, there'll be a Kahoot quiz where you guys get to test your knowledge. And I'll go through my class details if you're interested in weekly classes. And I'm doing these crash courses for free, right? So all I ask in return is for you guys to fill up this feedback form in the end. Okay? All right, if not, without further ado, let's begin. Okay, before we start with electrolysis of aqueous solutions, right, I want you guys to understand one thing. Okay? So before we start, I want you guys to remember this. Okay, remember anox rate cap. So what does anox rate cap mean? So N and ox is anode oxidation. Okay, then rate is reduction. Cat is cathode. Okay. So basically, if you don't know what anode and cathode is, just think of it as like objects that can conduct electricity. Okay. Think of it as objects that can conduct electricity. So what I'm saying here is that at the anode, right, the process that will take place is always oxidation. Okay. And then at the cathode, the process that will take place is always reduction. Okay, in the whole chapter of electrochemistry is like that. And then more specifically, we're going to be talking a lot about electrons. So we need to understand that oxidation is loss of electrons. Okay, reduction is gain of electrons. Okay, for those who just joined, I'm just going through this before we start the whole chapter. Okay, which is basically anode oxidation will take place. At the cathode, reduction will take place. This is for the whole chapter of electrochemistry, okay? So it doesn't matter if your anode is placed at the positive terminal or the negative terminal, oxidation will take place. Then for the cathode, reduction will take place. Okay, so remember this, very important. Then now we can start electrolysis of your aqueous solution. Okay, so what is aqueous solution? Basically, when a substance dissolves in water. Okay, so for example, your substance can be NaCl, then water is H2O, right? So when NaCl dissolves in H2O, it forms an aqueous solution. Okay, aqueous solution is where water is your solvent. Okay, that means water is the one dissolving the substance. So since we got the substance and we have water, right? Your solution is a mixture of two types of electrolytes. Okay, electrolytes are basically compounds that contain mobile ions. So what are compounds that contain mobile ions? Could be your acid, your ionic compounds, all those. Okay, as long as they contain this type of ions, like Na plus, H plus, Cl minus, then if it's a compound, it's an electrolyte. Okay. So there are two types of electrolytes here. One is the cation and anion from the dissolved substance. So if we are talking about NaCl, what is the cation and the anion? It will be Na plus, okay, and Cl minus. Right. Then H plus and OH minus is from water. Okay, because water, right, it will go through reverse dissociation to produce these ions. Okay, that means in your sodium chloride solution, in total there are 4 ions. Okay, let's look at other examples. So other examples of aqueous solution, you have HCl. So from the substance itself, HCl, when it dissolves, you will have what? H plus and Cl minus, right? From the substance itself. And then from water, it is always H plus and OH minus. Okay? So now you have 2 types of cations and 2 types of anions. Okay, but just nice, this is both H plus lah. So it's the same cation. Okay, but you have different anions, Cl minus and OH minus. Okay, then another example of an aqueous solution will be your concentrated NaCl solution. Okay, so doesn't matter whether it's dilute or concentrated, they are both solutions. So from the dissolved substance itself, you have Na plus and Cl minus. Okay, from NaCl, you got Na plus and Cl minus. And then from water, you have H plus and OH minus. Okay, it's very important to understand how to find all the ions up in your electrolyte. Okay, then the last example, aqueous CuSO4 solution, copper 2 sulfate. So from copper 2 sulfate, of course, you have copper and sulfate, right? So Cu2 plus and SO42 minus. Okay, but you also have 2 more ions from water, which is H plus and OH minus. Right? So basically, when you want to find the ions, right? When you want to find the ions of the solution, the first thing you should find will be from the actual substance, from the dissolved substance, which is if the substance is sodium chloride, then you have sodium and chloride. Okay. The second thing you want to find is the water. Okay. Water is always H plus and OH minus. So you just have to remember that. Okay. All right. So what exactly is electrolysis of aqueous solutions? Let me give it to you in drawing. Okay. So if you guys have like a pen right now, right, and a piece of paper, you can draw with me also. It will help you understand even clearer what exactly is electrolysis of aqueous solution. Okay. So draw these 2 straight lines side by side. Okay, then here you have your electrolyte. So remember what I said, what is an electrolyte? It's basically a compound that contains mobile ions. Okay, ions that can move freely to conduct electricity. Okay. And then you branch out this road into 2 pathways. Okay, one is the cathode, the other is the anode. Okay, so in your electrolyte, right, you have both cations and anions, correct? So we can split them up. One side is cations, the other side is anions. Okay, cations is your positive ions, like sodium and hydrogen. These are your cations. Anions are your negative ions, like chloride and hydroxide. Okay, so these ions come from your electrolyte, okay? These ions come from your electrolyte. Now here's the thing. In your electrolysis, right, of aqueous solution, your cathode is the positive terminal. Your cathode is the negative terminal. Your anode is the positive terminal. Okay, and we know that opposites attract, right? Positive attract negative, negative attract positive. So your cations, they are positive, right? So they'll be attracted to the negative electrode. Okay, so cations go to cathode. Very easy to remember, right? Because both of them got a cat. So cations go to cathode, anions go to anode. Okay, so we started off with the electrolyte. You can think of it as branching into 2 different paths. Okay, so now your cations are here, right? I'll just draw some plus to show that they are cations and some minus to show that they are anions. Okay. Then at the electrodes, reactions will take place, right? Exactly what reaction? Remember, just I said at the anode, it will be oxidation. At the cathode, it will be reduction. Okay, that's why I tell you to remember this memory shortcut and odds rate cap, because this will apply for the whole chapter of electrochemistry. So oxidation is loss of electrons, right? And then reduction is gain of electrons. So over here, it can either be the electrode takes part in the reaction or the ions take part in the reaction. But just now, what did we learn? This electrolysis of aqueous solution is using inert electrodes. Okay, inert means unreactive. So your electrodes do not take part in the reaction. Okay, so it can only be your ions up. Definitely, it will be the ions that take part in the reaction. Okay, now the problem is we have more than one type of cation, right? Here we have sodium, here we have hydrogen. Okay, here we have chloride, here we have hydroxide. So this is like a race, okay? There can only be one winner. So only one cation and one anion will be selectively discharged, meaning that they will turn from ions to atoms. Okay, that's what it means by discharge. So how to choose who is the winner? How to choose whether it's sodium or hydrogen? How to choose whether it's chloride or hydroxide? Now we will learn that. Okay, so this thing is called selectively discharge of ions. Okay, we start with the cathode. The cathode, you have cations, correct? So how to choose is the lower position in the reactivity series. Okay, so if you are Sec 4 by now, you should already learn the reactivity series. Okay, so I won't go too much detail into that. But basically, the lower position in the reactivity series, that will be the one that is discharged. So we look at this example, right? You have sodium and you have hydrogen. Sodium is here. Hydrogen is here. Hydrogen is the lower one in the reactivity series. So what does that mean? Your H plus will be selectively discharged. Okay, so your H plus ions will turn into hydrogen atoms. Understand? Then your sodium, nothing happens to it lah. Nothing happens to the sodium. It just remains as the ion. Okay. Then what about your anode? Okay, your anode, which is your anions. Okay, so there are dilute solutions and there are concentrated solutions, right? For dilute, we use this rule. Okay. Then for concentrated, we use this rule. So for dilute solutions, it will always be OH minus up. Okay, basically it's the lower position in the electrochemical series. That means this is the electrochemical series up. I recommend you don't have to memorize this. Okay, why? Is because the ease of discharge increases as it goes down the group, right? And you realize that OH minus is actually the lowest. Okay, and in all your dilute solutions, you will have water, right? You have a lot of water. So your water is made out of H plus and OH minus. So there definitely will be OH minus ions. That means OH minus is always the one to be selectively discharged. Okay, so if I'm talking about dilute solutions, OH minus will be the one that is selectively discharged. Okay, then for the half equation, there's only one, and this one no choice lah, you have to memorize. 4OH minus give you 2H2O plus O2 minus. Okay, for the rest, right, you know how many electrons is gained, how many electrons is lost, but this equation is pretty hard to write on its own. So I recommend you just memorize this. That means when OH minus is selectively discharged, right? And then they ask you to write the half equation for it, you write this. Okay? Okay, then moving on to the last one, which is your concentrated solutions. For concentrated solutions, for the anions, we look at the more concentrated anion. Okay, so think of it. In a concentrated sodium chloride solution, right? Sodium chloride solution contains what? Sodium chloride and water. Okay, will there be more sodium chloride or more water? Okay, I want you guys to answer this. In a concentrated sodium chloride solution, will there be more sodium chloride or more water? Okay, 1 or 2. More NaCl, yes, correct. More sodium chloride. Okay, since there's more sodium chloride, there will be a higher concentration of sodium ions and chloride ions. Make sense? Higher concentration of sodium ions and chloride ions, then lower concentration of H plus and OH minus. So, since we have more concentration for Cl minus, Cl minus is selectively discharged. Okay, so if we are talking about concentrated sodium chloride, now it will be Cl minus. This one will be selectively discharged. So your Cl minus will turn into the atom, which is chlorine gas. Yeah, so this is actually just the whole process of electrolysis. Your electrolyte become the ions, right? Then the ions, some of it will turn into atoms. Then some of it will remain. Okay, that's about it. Then you just have to remember all these rules. How do you selectively discharge your cations, your anions? Okay. So if it doesn't make sense to you yet, we'll go through 2 examples. Okay. One example is dilute sodium chloride. The other example is concentrated sodium chloride. Okay, I know we really love to use sodium chloride because it's the easiest example. Okay, I want you guys to look at example 2 first. Okay, electrolysis of dilute sodium chloride solution. Okay, so the first thing I do, right, when I'm answering electrolysis question is write down all the ions present in your electrolyte. Okay, so my electrolyte is dilute sodium chloride solution, right? So what are the ions present? Firstly, we have sodium chloride. So of course, we have sodium ions and chloride ions. But we also have a solution, right? What does a solution contain? Water. Okay, H2O. That means sodium chloride dissolves in water. So from water, we also have 2 more ions, H plus and OH minus. Okay, this one will be your products lah. Later we'll see why. Okay. Then of course we are using carbon electrodes, which are inert. Okay, remember your inert electrodes are either carbon or platinum. Okay, then other forms of carbon is like graphite. Okay, so carbon or platinum. Yeah. So your electrodes will not take part in the reaction because they are inert, they are unreactive. Okay, so let's see what actually happens at the cathode and the anode. That's the most important part. We start at the cathode, okay? So the ions present are H plus and Na plus. Okay, I forgot to write Na plus. Okay, why? Remember I mentioned your cations are attracted to the cathode. So the ions present there will be all your cations. So how do I pick which one is selectively discharged? Remember the notes here. For selectively discharge of cations, we pick the lower position in the reactivity series. Okay, so we have sodium. Again, we have sodium and hydrogen, right? Hydrogen is lower in the reactivity series, so your hydrogen ions will be selectively discharged. Okay. Wait. This one, yeah. H plus ions are selectively discharged because it has a lower position in the reactivity series compared to sodium. So pretty straightforward. Okay, then how to write the half equation? Okay, we know at the cathode what happens? Reduction, right? I'm going to show you guys step by step how to write the half equation. Reduction happens at the cathode. What is reduction? Gain of electrons. So the first thing I do is write this. H plus gains electrons to form H. Okay, makes sense? Hydrogen ions gain 1 electron to become the atom, right? Because hydrogen has a valency of 1 only. But why isn't this the final answer? Because hydrogen is diatomic. Okay, diatomic means that it exists as 2 atoms that are covalently bonded together. So if I have to add a 2 here, right? Since it naturally exists as H2, I have to add 2 here and 2 here also. So this is our final half equation. Okay? Understand? Now I move on to the anode. Okay, so what is attracted to the anode? Can you guys tell me? What is attracted to the anode? Please type down your answer. Okay, so it's your negative ions, right? Your anions. Okay, you all need to remember, right? Your positive terminal is your anode. Your negative terminal is your cathode. For this electrolysis, for electrolysis of aqueous solutions. So your negative ions will be attracted to positive. Then your positive ions will be attracted to the negative. Okay. So both of these ions will be attracted. Okay, not just OH minus. Remember, both ions will be attracted, but only one will be selectively discharged. How to choose? This is dilute, right? Dilute solution. Let's look. How do we choose? Position in the electrochemical series, which will always be OH minus. Okay, just remember dilute solution, the anion that is selectively discharged is always OH minus. All right, so OH minus will be selectively discharged because it's always at the lowest position in the electrochemical series. So it cannot compare to anything else. So it will always be the one that is selectively discharged. And then, like I said, this half equation you have to memorize. Okay, there's no point thinking of how to write it down. So you have to memorize this half equation. 4OH minus gives you 2H2O plus O2 plus 4E minus. Okay. By the way, right, if they write plus 4 electrons at the right-hand side, it means OH minus loses electrons. Okay. Because the plus electrons is on the right-hand side. So the one on the left-hand side loses electrons. So that's how we demonstrate losing electrons in chemistry. Okay, in chemistry, we don't write minus electrons. Okay, we don't do that. We always put it at the right-hand side, then we put a plus. Okay, then overall chemical equation. Let me teach you guys how to write. Okay. Okay, the first step is to balance the electrons. So what I mean by balance, that means both sides will have to be the same number of moles of electrons. So here I got 4 moles, right? Here I got 2 moles. So I have to multiply by 2 here to make it 4 moles. So once I multiply, right, I will have 4H plus 4E. E minus is electrons, by the way, and then 2H2. Okay? Okay, so now there is balance. You want to cancel out repeating substances in both half equations. So for example, electrons that are repeating, right? Here I have 4 electrons, here I have 4 electrons, so I cancel out. Okay. Then if you realize, right, I have a 4H plus here, 4OH minus here. When I combine these two, it's the same thing as 4H2O, right? So I have another repeating substance because here I have 2H2O, here I have 4H2O. So if I cancel and cancel, I'll be left with 2H2O on the left-hand side. Okay? So the third step is to combine. That means whatever you see in your half equation, on the left-hand side, you combine together. On the right-hand side, you combine together. So on the left-hand side, now we are only left with 2H2O. Okay? So this will be written down. And then on the right-hand side, we have O2 here, right? And we have H2 here. Okay? Specifically 2H2O, because we already balance it. So you have 2H2 plus O2. Okay, and that's how you write the overall chemical equation. All right, I repeat. First step is to balance the electrons. Make sure the electrons, the number of moles are the same on both half equations. Second step is to cancel out those repeating substances on the left and the right. Okay, that means something from the left here and something on the right here is the same. You cancel them out. Then the last step is to combine everything on the left-hand side. That means your 4OH minus, 4H plus, 4E minus, everything combined. Okay, if I never cancel them out. And then on the right-hand side, I have these two. Okay, on the right-hand side of the equation. So once you combine, you get this. So what can we tell from the electrolysis of dilute sodium chloride? We can tell the ratio of the things collected, okay, of the gases formed. So first, we know from the overall equation that hydrogen and oxygen is formed. Okay. Okay, we have a question. Why does the overall equation not contain H2O? There is H2O here, 2H2O. Okay, so what do you mean by doesn't contain? We have 2H2O to give you 2H2 plus O2. Okay. So the ratio, right, of H2 to O2 is 2:1. That means during electrolysis, right, you always have 2 times the number of moles of hydrogen compared to oxygen. Okay, that will be the same throughout. So we can tell the ratio. Then the other thing we can tell is that it's only your water molecules being electrolyzed. Like you realize the overall chemical equation, right, is just water being electrolyzed. Okay, electrolysis is basically breaking down a compound into simpler substances. Okay, so we are breaking down water into hydrogen and oxygen. That's why we call this whole thing electrolysis of water. Okay, so electrolysis of dilute sodium chloride is essentially electrolysis of water. So if you think about it, if only water is being electrolyzed, right? I have dilute sodium chloride here. So originally I have a lot of water, right? Because the solution is dilute. But after water is being electrolyzed, the amount of water will decrease, right? And then the concentration of NaCl will increase because there is less water. So this solution will quickly become concentrated sodium chloride. Okay. Then since our electrodes, right, we are using carbon, it has to be replaced regularly. Okay, because oxygen reacts with carbon to form carbon dioxide. Yeah. So all these things we have to know. These are the things that we can analyze. Okay, any other questions? So this is for dilute solutions. Okay, no questions. Let's move on to example 1. Okay, now electrolysis of concentrated sodium chloride solution. So this is concentrated, we have to take note, and again sodium chloride solution. So what's the first thing I do? Write down all the ions present. Okay, so from sodium chloride we have Na plus and Cl minus. Okay, then from water we have H plus and OH minus. Okay, so remember the pathway thing, right? Your cations are attracted to the cathode, and then your anions are attracted to the anode. Okay, remember anode is positive, cathode is negative. Okay, so what are the positive ions at the cathode? You have H plus and Na plus, as usual. And then at the anode, you have Cl minus and OH minus. So it doesn't matter what type of solution you have. At the cathode, it's always the same way of choosing which ions are selectively discharged. Okay, which is the lower position in the reactivity series. So again, we have sodium and hydrogen, right? Hydrogen is lower in the reactivity series. So hydrogen ions will be selectively discharged. Okay, hydrogen ions are selectively discharged, and then the half equation is the same. Okay, the same as how I explained just now. You just write it down the same way. Okay, so once you know which ions already, right, immediately you will know the half equation. Okay, all the half equations are same for the same ions. Okay, so at the cathode, reduction happens. So this is the gain of electrons. Okay, as you can see, electrons are being gained. Now we are at the anode. At the anode is oxidation, so loss of electrons. Okay, so let's see. The ions present are Cl minus and OH minus. Okay, so how do we choose which are selectively discharged? For concentrated, we look at the concentration effect. Okay, so in a concentrated solution, the more concentrated anion will be selectively discharged. Whichever ion with a higher concentration will be selectively discharged. Okay, so now I have a question for you guys. Which ion here has a higher concentration? Okay, this is concentrated sodium chloride. So is it Cl minus or OH minus? Which one will have a higher concentration? Okay, if it's Cl minus, you give me a 1. You type on number 1. If it's OH minus, you type number 2. Okay, I want to see your guys' answers. Which ion has higher concentration? 1 or 2? Okay, good. Yes, correct answer is 1. Okay, chloride ions are of higher concentration. So they will be the one that is discharged. Okay, so now listen carefully on how to write the half equation. Because by looking at this, it might look confusing, right? But I'm going to explain step by step. Okay, so let me do it here. We know that at the anode, you lose electrons, right? So your chloride ions, I just write it down first. It will minus electrons because it loses electrons to form chlorine. Make sense? Okay. Your chloride ions got 7 valence. Oops, got 8 valence electrons, right? Okay. So it has to lose one to become its atom, which is 7 valence electrons. Okay, chlorine is in group 17, so you just have to lose 1 electron only. But this is not the final answer lah. Okay, there are 2 things we have to do to this. Firstly, chlorine is diatomic. Diatomic, meaning it exists as 2 atoms covalently bonded together. So there's a 2 here always. So now I must add a 2 here, I must add a 2 here. Okay, but we're still not done. In chemistry, we don't like to write minus electrons. So we'll move it over to the right-hand side. And that is your half equation. Okay, so just add in the state symbols and you're done. Okay, now moving on to the overall chemical equation. Now this one is slightly tricky, okay? Let me erase all this first. Okay, where shall I write this? Okay, I write here. First step, balance electrons. Okay, so the first step is always the same. You balance the electrons. Oh, just nice. It's already balanced for me, right? 2 electrons and 2 electrons. Then the next step, we want to cancel out whatever is repeating, right? So whatever is repeating now is the electrons. Okay, so we cancel them out. Okay, but now we realize, right, if we go to the third step, which is combining the left-hand side, what do we have when we combine the left-hand side? You got 2H plus and 2Cl minus, right? Which is basically 2HCl. But let's use common sense here. Does it make sense that we started off with 2HCl? Does it make sense that 2HCl should be at the start on the left-hand side of the equation? Remember, we start with what? Concentrated sodium chloride solution. So why out of nowhere we have 2HCl? Okay, cannot be, right? So we can't use this method of combining straight away. Okay, if you realize, right, if you combine and you get a totally different substance at the start, that means it's either it's not the substance here or it's not water, then you have to use this second method. Okay. Okay, so first thing, cancel out the repeating substances. Okay, then now you have to just copy down original electrolyte. Okay, what is the original electrolyte? Sodium chloride solution. So sodium chloride solution contains NaCl and H2O, right? And then remember, we want to follow the mole ratio, right? There's a 2 and a 2. So we have to write that down. Okay. So if you realize that the beginning, right, the beginning electrolyte is not the same, then you have to use this method, which is copy down everything, your original electrolyte. Then draw an arrow. Okay. Fourth step, copy down right-hand side of both half equations. So at the right-hand side of both half equations, we have, I use this color, we have Cl2 and H2. Okay, now we can just copy them down. Very simple. Okay, but there's one last step. Write down the remaining electrolyte. So, what is remaining electrolyte? That means, right, we have 4 ions, right? Not everything got selectively discharged, all right? There will still be something remaining as the solution, as the electrolyte. So how do we know? We know that chloride ions are being selectively discharged. H plus ions are being selectively discharged. So what is left? Can anyone tell me what is left in the solution? After chloride ions and hydrogen ions are selectively discharged, we are left with these 2 ions, right? So what is the compound in the electrolyte that is left? Okay, if we are left with these 2 ions, oops, let me use this color. If we are left with these 2 ions, what is the compound that is remaining in the electrolyte? Anybody? NaOH. Yes, good. Okay, so it will be NaOH. Okay, then we add a 2 to balance the equation. So that is how you write the overall chemical equation. If your original electrolyte is not correct. Right? Okay, now what can we tell from this? The ratio of your gaseous products. So your gaseous products are hydrogen and chlorine, right? The mole ratio is 1:1. So we know that the ratio of those is 1:1. Okay? That means if here I collect about 40 dm cube of chlorine gas, here will be about the same. Okay, the only difference will be because chlorine is soluble in water, so some of the gas will dissolve. Okay, then the solution gradually becomes alkaline. Why? Because originally you have the same amount of H plus and OH minus, right? Then once your H plus ions are selectively discharged, now you have a higher concentration of OH minus compared to H plus. Okay, compared to H plus. So being alkaline basically means that you have a higher concentration of OH minus. Okay, because you are left with sodium hydroxide. And then you can test this by using a universal indicator, which will turn purple or violet when add to the solution. All right, so those are your two examples of electrolysis in aqueous solution. Okay, don't worry if you cannot copy down everything. I will send my inkings to the Telegram channel. Okay, after the crash course. All right, so now I'll go through the question. Okay, so an experiment is carried out to electrolyze concentrated aqueous sodium chloride. Okay, so this is concentrated aqueous sodium chloride. Write the half equations for the reactions at the cathode and the anode. Okay, just to remind you, cathode is negative here, anode is positive. Okay, so what's the first thing I want to do? Write down all the ions. So we have Na plus, Cl minus from sodium chloride. And then from water, we have H plus and OH minus. Okay, so write the half equations for the reaction at the cathode. What is attracted to the cathode? Your cations, right? Your positive ions. So what are the possible positive ions? Na plus and H plus. Okay, only one will be selectively discharged. There will only be one winner. So we decide that by using the reactivity series. Please stop calling me cool zebra. Alright, that's just the acronym I use up for the reactivity series. Alright, so we compare sodium and hydrogen. Hydrogen is obviously lower. So that will be the one that is selectively discharged. Okay, so H plus gains electron to form H. Okay, I remember, right? Cathode is always reduction. Reduction is gain of electrons. So I always put plus electrons. Then I know H is H2, right? Hydrogen is diatomic. So I add a 2 here, add a 2 here, and then add the state symbols, and that is your half equation. Right? Okay, moving on to the anode. So your anions are attracted to the anode. Okay, so I'm considering Cl minus and OH minus. Okay, your negative ions. So how do I choose which one is selectively discharged? First, you must see whether your solution is concentrated or dilute. So obviously this one is concentrated. So if it's concentrated, we look at the concentration effect, meaning the more concentrated anion wins. Okay, the more concentrated anion will be selectively discharged. So if your solution is sodium chloride, that means your chloride ions will be of higher concentration. Okay, so they will be selectively discharged. And this is your half equation. So just a showcase of how I get to this half equation again. Chloride ions. What happens at the anode? Oxidation, right? And ox rate cap. Anode oxidation. Oxidation is the loss of electrons, so minus electrons to give me chlorine. Okay, chlorine is diatomic, so add number 2, and then I have to balance the rest. Okay, then in chemistry, we move the minus to the right hand side. And that is how I get the half equation. Okay, let me know if you have any questions as I go through. Okay, then overall equation. Yeah, remember I said if you combine the left, right? If you combine these two, this and this, you realize it's 2HCl, right? And it doesn't make sense because we didn't even start with HCl. We started with sodium chloride solution. Okay, so it can either be sodium chloride or water. But we have HCl, so we can't use the original method of combining. First, we balance the electrons, and then we cancel the electrons, right? Can cancel these two. Okay, then now we copy down the original electrolyte. Sodium chloride, water. Here we copy down exactly. And then I wrote a 2 because originally it has 2 already. We want to copy the same number of moles. Okay, arrow. Now we copy the right hand side. Okay, use different color. H2 and Cl2. Okay. And the last step is to write down the remaining electrolyte. So we know that H plus is being selectively discharged. Cl minus is being selectively discharged. So what is left? Na plus and OH minus. So you have NaOH. Okay, and then you add a 2 to balance the equation. Okay, then if you want to write the state symbols, these are the state symbols. Okay, for ionic half equations, you should write the state symbols. For overall equation, it is not necessary. Okay, the gases are collected and their volumes are measured. Okay, so you have chlorine gas collected and hydrogen gas collected. And then they measure the volume. Explain why the volume of chlorine gas collected is lesser than expected. Okay, this one is because chlorine is soluble in water. Okay, so you know how chlorine is produced here, right? Because your reaction happens at the electrolyte. I mean at the electrode, sorry. So some of the chlorine will be inside the water. Then they will dissolve, some of the chlorine will dissolve in the water. So you will have lesser chlorine gas. Make sense? Lesser chlorine gas. Explain why sodium metal is not produced in the solution, in the reaction. Because when I got to the point of selectively discharging the ions, right? Sodium didn't win. Hydrogen won, right? Why did hydrogen win? Because okay, I should use the symbol. It's easier. Hydrogen is below sodium in the reactivity series. Okay, remember for cations, we use the reactivity series to judge which one is selectively discharged. So since hydrogen is below sodium, your sodium ions will be selectively discharged. To form hydrogen gas, okay, instead of sodium. That's why sodium metal is not produced up, because it's your hydrogen ions that are the ones selectively discharged. Good question. Okay, so usually, right, when you answer chemistry question, and you want to write a symbol, usually for hydrogen we write as H2, right? But now we are comparing the two elements in the reactivity series. So in the reactivity series, you don't write it as H2, right? That's why I write it as H. Yeah. But if you're talking about producing hydrogen gas, it is advisable to write H2. Okay. But if you are writing as reactivity series, you can just write a H. All right. Let's move on to industrial application of electrolysis. So how do we actually apply electrolysis in industrial ways? Okay. Firstly, we use reactive electrodes. Okay. Reactive electrodes. These are electrodes that will take part in the reaction. Okay, they will take part in the reaction instead of your previous one. Previous, we had inert electrodes, right? That means they're unreactive, they don't take part in the reaction. But now your reactive electrodes can take part in the reaction. So let's look at the first application, electroplating. Electroplating is the process of coating an object with a layer of desired metal. That means, let's say you have a toy, right? You have a toy, and then you want to coat the toy with silver. You can electroplate the toy with silver. Okay, but the toy has to be magnetic material. Sorry, has to be a material that can conduct electricity. Okay, so usually the most common case will be a spoon lah. You know, your spoon, right? Some people would like to coat it with gold or silver. So when they coat it with gold, they can use electroplating. When they want to coat it with silver, they can also use electroplating. So in electroplating, the substance, the object at the cathode, is the object that you want to be coated. So if you want to coat a spoon, the cathode will be the spoon. Okay, it will be a spoon. And then at the anode will be the metal that you want to coat the object with. So if I want to coat the object with, let's say, silver, at the anode it will be silver. Okay. And still remember, the cathode is still the negative terminal. Anode is still the positive one. Okay, then your electrolyte, right, has to be a soluble compound or substance with the metal ion. That means if I want to use silver to coat the object, this has to be, for example, silver nitrate. Okay, silver nitrate or any soluble silver compounds basically is to contain the exact same metal as an ion. Okay, so how do I remember which is the cathode and which is the anode? Very simple. If your object gains mass, right, it gains electrons. Okay, gain and gain. Gains mass, gain electron. And gain electron, what do we know about that? That is reduction, right? We also know that what happens at the where does reduction happen? Happens at the cathode. So if your object gains mass, ultimately it will be the cathode. You realize your spoon, right? You want to coat it with silver. So before, it is just a regular spoon. And then after, it will be a spoon with silver. So the mass increases. Since the mass increases, we think of it as it gaining electrons. Okay, so it's reduction, which happens in the cathode. That's how I remember lah. Then the object that loses mass, right? Think of it as it losing electrons. And what is losing electrons? Oxidation. Oxidation happens at where? The anode. So the object loses mass is the anode. Think about this metal here. This metal here will dissolve in the water. It will dissolve to form the ions. Then the positive ions will be attracted to the cathode, where it is discharged. Okay, so I just mentioned the whole process already. If we use this example of coating a spoon with silver, this is your silver anode, right? It will lose electrons to form silver ions. Okay, silver ions. These silver ions, it will enter the solution. Okay, remember I said your solution, your electrolyte has to contain the metal ion, right? So that metal ion is silver now. It will enter the solution. Okay, let me erase all this. Enter the solution already. It will enter the solution. And then cations are attracted to the cathode, right? So it will move to the cathode, which just so happens to be your spoon. Okay, your cathode is your spoon. So it will be discharged there. So what happens here? It gains electrons because reduction happens at the cathode to form silver. And now this silver is being formed on the spoon. Okay, full of silver everywhere. That is electroplating. Okay. So uses of electroplating will be to make an object more attractive in appearance. Okay, that's one. Like that's why all those rich people, they like to coat their spoons with silver or gold, right? To make it look more attractive, more atas, right? Then another one, which is more useful, is to prevent another metal from corrosion. Okay, if you learn reactivity series, you will remember your sacrificial protection, right? To prevent iron from rusting. This is an example, electroplating, an example of sacrificial protection. Okay, you coat a metal with another layer of a more reactive metal so that it prevents it from corrosion. Okay, any questions on electroplating? Okay, if no questions, let's look at purification of metals. So again, we follow this rule. The object that gains mass will be the cathode. The object that loses mass will be the anode. Okay. So purification of metals is basically removing impurities from a pure metal. So let's say you have a pure metal of silver, right? And there are some impurities here. Purification is basically removing the impurities. But how does it actually work in the electrolysis process is you remove the metal so that you are left with the impurities. Okay, that's how they like to remove it. So let's look. So that gives you a clue already whether this sample with impurities is the anode or the cathode. I just told you that you remove the metal, right? So that loses mass. The whole thing of that will be lost. So if it loses mass, it is the anode. Okay, at the anode will be your sample containing impurities. And then at the cathode, it will be the actual pure metal. Okay, a thin sheet of the actual pure metal. That means this one is the one with no impurities, the pure metal. Then this one is the one with impurities. Okay, this is your anode, this is your cathode. Okay, so what will happen if this is silver, right? This is silver. Since it's at the anode, it will oxidize. It will lose electrons to form silver ions. So again, your electrolyte has to contain silver ions. Okay, so this silver will dissolve in the solution to form silver ions. Then your silver ions will travel, and be attracted to the cathode. It will be attracted to the cathode, which is a negative terminal. Okay, then your cathode is the pure metal. So over here, what happens? What happens at the cathode? Reduction, right? Gain of electrons. So your silver gains electrons to form, your silver ions gain electron to form silver. So whatever silver that is lost here, right, will be transferred over here. Does that make sense? That means I have 2 bars of silver. 1 bar got impurities. So how does it remove the impurities? I remove the whole silver here and I bring it over here. Okay? Then over here, I'm left with the impurities. So now I just separated the impurities from the silver. Okay, that is purification of metals. Yeah. So what is left here? Nothing. Then all the impurities will sink to the floor. I mean the beaker. Okay. That is purification of metals. Okay, 9:04 already. We have to quickly finish up these questions. Okay, a metal object is electroplated with silver. Which rule correctly describes the electrolysis cell used? Okay, so you have electrolyte in aqueous solution, positive electrode, negative electrode. Okay, so your positive electrode is your anode, and then your negative electrode is your cathode. Okay, so remember I said your electrolyte has to be soluble and contain the metal ions, which is silver. So all of them contain silver ions, but only 2 of them are soluble. Okay, your soluble is nitrate lah. Nitrates are always soluble. Silver iodide is insoluble. Okay, this one you have to remember your solubility table. Your iodides act the same way as chlorides. So silver chloride is insoluble. Silver iodide is also insoluble. Okay, so answer can only be C or D. Let's see. At the anode will be the thing that loses mass. The cathode is the one that gains mass. So what is the goal? The goal is to coat a metal with silver. So silver will lose mass. Okay, then the metal will gain silver, right? So it gains mass. So which one gains mass? Is the cathode. This one lose mass is the anode. So your answer is D lah. Okay, you see how I just broke down everything? So it's very simple. You know that silver loses mass, so it's the positive electrode, your anode, and then your negative electrode gains mass. Your metal gains mass. So it's the object to be plated. Okay, electroplating can be used to coat one metal with another. Draw a label diagram of an apparatus that can be used to coat an iron spoon with a layer of silver. Okay, so always start off with your battery. Positive, negative, positive, negative. You draw these 2 lines. Okay, make sure you use a ruler when you're drawing. Okay. Then you have iron spoon and you have a layer of silver. Okay, they meant layer. So your iron spoon will gain mass, right? It will gain the silver. So it is the cathode. Okay, the cathode gains electrons. Then your layer of silver will lose mass. Okay, it will dissolve in the solution. So it is the anode. Okay, so anode is positive, cathode is negative lah. So you have to draw your spoon at the cathode, and then the anode, just draw a regular rectangle. Okay. Oops. Okay, I can draw this straighten line. Then okay. Then now draw the electrolyte, right? your electrolyte, just make sure it's submerge your electrodes. Okay. Then this electrolyte has to contain silver ions. So let's say silver nitrate long. It has to be soluble. Right? And this is your iron spoon. And this is your silver. So write the half equation that occurs at the anode. Your anode is your silver, okay? What happens at the anode? Loss of electrons, right? Oxidation. So your silver will lose electrons to form silver ions. Okay, moving on. Simple cells. Okay, simple cells, they are really simple. Okay, no pun intended. Okay, so it's like the opposite of your normal electrolytic cell. Your normal electrolytic cell, right? They use electricity, which is electrical energy, then they convert it into your chemical reactions. This one is the opposite. You use your chemical energy and convert it into electrical energy. So chemical energy is your chemical reactions. That means your chemical reactions can take place without any electricity. Okay, it will take place by itself. And then because this chemical reaction takes place, right, there will actually be a transfer of electrons, okay, from one thing to another thing. And this transfer of electrons will produce electricity. Okay, simple, right? Chemical reaction causes the transfer of electrons, which causes electricity. That is how a simple cell works. Okay, so let's see how exactly is the setup. You have two metals of different reactivity. Okay, so one will be more reactive, one will be less reactive. And in chemistry, right, I don't know if a lot of teachers teach this, but you need to understand that more reactive metal has a higher tendency to lose electrons. Okay, we know metals, they lose electrons to form positive ions. But I don't know if a lot of teachers say the more reactive metal have a higher tendency to lose electrons. That means if I look at the reactivity series, right? Okay, let's just look at the top four metals. If I compare potassium and magnesium, potassium has a higher tendency to turn into potassium ions compared to magnesium turning into Mg2+. Okay, they are more reactive. There's a higher chance for them to lose electrons. So now that you understand that, if I have a more reactive metal and a less reactive metal, of course the more reactive metal will lose electrons. So that's why we have the transfer of electrons, which is this direction. Okay, the diagram already show you the direction. Basically, electrons will transfer from your more reactive to the less reactive metal. Okay, and because this is a chemical reaction, right? And you don't even need electrical energy, simple cells have no battery. Okay, so if you see a cell, right, there's no battery, immediately I know it is a simple cell. Okay, so usually they put nothing, either nothing or they put a voltmeter. Okay, your voltmeter is to measure the potential difference. Measure the potential difference. Okay, if you don't take physics, potential difference is basically the voltage, the amount of electricity. Okay, so now it's slightly different. Your more reactive metal is the anode and the less reactive metal is the cathode. Okay, and since electrons, right, we learn they transfer from negative terminal to positive terminal. Your anode is negative, then your cathode is positive. Okay, so it's completely opposite of electrolytic cell. Electrolytic cell, your anode is positive, and then your cathode is negative. But now it's different. Now your anode is negative and cathode is positive. because electrons flow from negative terminal to positive terminal. Okay, more reactive anode, less reactive cathode. Okay, but what stays the same? What stays the same? The transfer of electrons. Okay, the process that takes place at the anode. Remember, anode, oxidation, loss of electrons. Cathode, reduction, gain of electrons. It's still the same thing. The same processes take place at the same areas. Okay. Now let's see an example. Simple cell using magnesium and copper. So if I write down the reactivity series, magnesium is here and copper is here. So magnesium is more reactive, it will be the anode. Copper is less reactive, it will be the cathode. Okay? So this is how it looks like. The transfer of electrons will be this way. Okay, from magnesium to copper. Then as it's transferring the electrons, this voltmeter here will measure the voltage. Okay? So let's see what actually happens. Your magnesium is the anode, right? So what happens at the anode? Oxidation, which is loss of electrons. So your magnesium is oxidized by losing electrons to form magnesium ions. Okay, so the mass of magnesium will decrease because you can think of it like it's dissolving in the solution. So this is your half equation. Magnesium loses electrons to form Mg2+, your magnesium ions. All right, then moving on to the cathode. Your copper is your cathode. What happens at the cathode? Reduction, right? Gain of electrons. Can you send us the answers after? Yes. I will send the whole inkings of the whole notes in the Telegram channel, so you can find that there. Okay. So don't worry if you don't manage to copy any of the things here. Okay. So we were at copper cathode, right? Cathode gain of electrons happen. So your Cu2 plus ions, remember this is copper 2 sulfate, right? You have Cu2 plus ions here. It will be attracted to the cathode and it will gain electrons to form copper. Okay. So even though copper is a reactive electrode, the ones that take place in the reaction will still be the cations, because your cations gain electrons to form copper, to form more copper. So more copper will be formed here. Okay, that's why our observation is the mass of copper increases. Right, then your overall ionic equation, you just balance the electrons and combine them. So the electrons are already balanced, right? So I combine the left-hand side, which is Mg and Cu2 plus, right? Mg and Cu2 plus. And then the right-hand side, we have Mg2 plus and Cu. Okay, that's the overall ionic equation. There is no answer for this. This is just showing you the whole process. Then if they ask you what happens at the anode, you should be able to say, yeah. Okay, so in simple cells, the further apart the two metals in the reactivity series, the greater voltage produced. That means this is a reactivity series, right? If I compare sodium, if I compare sodium and silver versus zinc and silver, sodium and silver has a greater difference, right? So you have higher voltage. Then zinc and silver has a slightly more narrow distance, shorter distance. So it has a lower voltage. Okay, so the further apart the two metals in the reactivity series, the greater the voltage produced. Okay. So let's look at this question. A student conducts the following experiment to investigate the reactivity of 5 metals. Okay. A, B, C, D, and copper. So Figure 1 below shows the experimental setup. Metals A, B, C, D, and copper were used as electrode X. Both electrodes are immersed in dilute sulfuric acid. Okay, so dilute sulfuric acid is our electrolyte. Okay, then we have iron electrode and electrode X. So we already know that this is a simple cell just because there is no battery. Okay, no battery and a voltmeter. There's a voltmeter, so this is a simple cell. Okay. Furthermore, these are reactive electrodes. Okay, because they are all metals, right? So the results are shown below. If the metal used as electrode X is A, the voltage is positive 1.5, B negative 2.75, okay, and so on. Okay, the positive and negative just tells you the direction of the electron flow. Okay, that means if the original direction is like that, this is positive, then the negative one will be the opposite direction. Okay, so that is direction. Then after that, the voltage number is just how big the voltage is. So remember, the greater the distance between the metals in the reactivity series, the greater voltage. So state how the reading of the voltmeter is affected by the choice of the metal used as electrode X. Okay, so we don't know A, B, C, and D, right? So we don't know exactly where is the electron flow, but we know copper. Okay. So let me write down the reactivity series. Okay. So copper is here, iron is here. That means iron is the more reactive one. It will be the anode, right? Copper is the cathode. So iron will transfer electrons from iron to copper. That means the electron flow is like that. So when the electron flow is like clockwise, right? The voltage is positive. So now we know already lah. If the electrode X is more reactive, the voltage will be negative. Okay, then if electrode X is less reactive than iron, the voltage will be positive. So how the reading is, there are two things. We have to talk about the sign, the positive and negative sign, and the magnitude of the voltage. Okay, so we start with the magnitude of the voltage. The greater the difference in reactivity between your metal X and iron, what happens when there's a greater difference in reactivity? The greater the voltage produced. Okay, but that's not the end of it, right? We also have to explain why positive and why some negative. So if metal X is less reactive, that means if it's copper, right, which is less reactive, the positive reading will be obtained. And then if X is more reactive, than iron, a negative reading is obtained. Okay, that means the direction of electron flow will be opposite. Okay, then suggest an identity for metal C. Okay, so now, right, you guys can just listen and try to understand. Then after the crash course, when I send, then you guys copy. Okay, so that we can save time. So suggest an identity for metal C. For metal C, right, the voltage is 0. What could that mean? If the voltage is 0, that means there is no difference in reactivity, right? Only a difference in reactivity will cause the voltage to the electrons to flow. But if there's no difference in reactivity, chances are it's the same exact metal as the other electrode, which is iron. So iron is electrode. Iron is metal C. Okay, explain your answer. When metal C was used as electrode X, a 0 voltage reading was obtained. This shows that C has the same reactivity as iron. Okay? So if you see zero voltage, right, that means they have no difference in reactivity, meaning that both electrodes are the same metal. Okay? I'm going to move on. Place metals A, B, C, and D and copper in order of reactivity, starting from the most reactive. So we already know for most reactive, right, it will be, remember here I say, if X is more reactive than iron, a negative reading is obtained. So the most reactive one will have a negative reading with the highest number. So y'all can see for yourselves which one has negative readings. This one and this one, right? Which one has a higher number? This one. So B is the most reactive. And followed by the second one, right? D. Okay. Then it starts to go from a scale lah. Basically, iron is here, right? And then copper is here. And B, D is around here. So C is the next one because C is iron. Okay. Then now we move on to positive readings. The smaller reading will be more reactive. Okay, because now we are tightening the gap. Okay, so A will be here, and then copper is the least reactive. Oh, somebody asked what's zero voltage. Yeah, okay. Then Emmeline answered. Thank you for answering. Okay, suggest the value of the voltmeter reading if metals A and B were used as the electrodes in figure 1. Okay, so if metal A and B were used, right, what is the value of the voltmeter? So they just want the value, they don't care about the sign. Okay, so how do I get the answer? I know that from iron to A, right, it is positive 1.5 volts. Okay, then from iron to B, it is negative 2.75 volts. So B to A will be 1.5 plus 2.75. Okay, it is just the longest distance. So what is 2.75 plus 1.5? 4.25. Okay, yeah, 4.25. So the value is 4.25 volts. Okay, can I ask all of you to go to the Kahoot now? And we will start a set. Sorry, I will end a few minutes late. Yes, please ask a question. Why is question 2 not B? Question 2. Okay, because B, right, the electrolyte is silver iodide. Okay, silver iodide, basically iodide will have the same properties as chloride. So think of silver iodide as silver chloride. Silver chloride is a precipitate. It is insoluble in water. So if it's insoluble in water, that means it cannot dissolve in water to form any mobile ions. Okay, but for electrolyte in aqueous solution, we want to make sure that they contain ions that can move. Okay, especially the silver ions need to be able to move about. So if it's insoluble, then it cannot be used as an electrolyte. Okay, does that make sense? Not iodide is insoluble in water. Silver iodide is insoluble in water. Okay, there are only two iodides lah. Silver and lead. This one have to remember your solubility table for chloride. Okay, silver chloride and lead 2 chloride. They are both insoluble. So it's the same for iodide. Then the rest, they are soluble. Okay. Yes, correct. So metals lower than hydrogen, they are more likely to be discharged. Okay, as long as it's lower in the reactivity series. Okay, good. Your Cl minus will be discharged in concentrated NaCl. Okay, at the anode. Because at the anode is where your anions are attracted. Okay, so in electrolysis using, hold on. In electrolysis of CuSO4 using carbon electrodes, which ion is discharged at the cathode? So at the cathode, you have your cations. The cations present are CO2 plus and H plus, right? We always choose the one lower in the reactivity series. So if you look at the reactivity series, copper is actually lower than hydrogen. So CO2 plus will be discharged. Okay, not hydrogen. So it's the one that is lower. Okay, what happens to the color of electrolyte during electrolysis of CuSO4? So during electrolysis of CuSO4, the ions that are discharged, right, is copper, CO2 plus, and OH minus. Okay, but for copper, right, if copper ions are discharged, then the blue color will slowly fade away, right? Because copper 2 sulfate is blue because of the copper 2 ions. So if there is CO2 plus copper 2 ions being discharged, the color will fade away. Okay, so it'll turn from blue to colorless. So what is the half equation at the cathode during electrolysis of zinc bromide? So immediately when I say cathode, you have to think cathode is cations. Okay, so what are the cations in zinc bromide? Zinc ions and hydrogen ions. Hydrogen is less reactive than zinc, so hydrogen ions are the one that are discharged. Okay, so the half equation will involve hydrogen ions. Yes, reactive electrodes, good. Okay, after the Kahoot, can you go back to every question for 5 seconds? Okay, cathode, yes. So the object to be plated should be the cathode. Good job. Okay, silver should be placed at the anode, okay? There won't be any more carbon because carbon is inert, right? We want reactive electrodes. So the one placed at the anode is the one that loses mass, and the one that loses mass is the one that you use to electroplate. You use a spoon to, you use silver to electroplate a spoon, right? Right, good job, Yutong. Okay. So it's the anode that loses mass, okay? So it's the anode. Okay, good. Yes, simple cell is chemical energy to electrical energy. Okay, 5 more questions. Which is the negative electrode? Remember, a negative electrode in simple cell is the anode. So think carefully, which one is the anode? The anode is the more reactive metal. Okay, it doesn't depend on the electrolyte. As long as the more reactive metal, it is the anode. Right. Okay, good. Difference in reactivity will determine the voltage. Good. Mass of anode decreases. So the magnesium being the more reactive one will be the anode, and it will dissolve in the solution to form magnesium ions. So the mass of the magnesium anode decreases. Good. A power source is present in electrolytic cell but not in a simple cell. Okay, last question. All right. So zinc and copper are used as electrodes in the simple cell. What is the half equation at the anode? So the anode is the more reactive metal. Zinc and copper, which one is more reactive? Zinc. So zinc will be oxidized at the anode to form zinc ions. Okay, oxidized will lose electrons. So answer is green. Okay. Oh, okay, your mom is the one with access. Okay. Good. So I'll just send the link of the Telegram channel here. Wait, let me share my screen back to the thing first. Okay, can you all please fill up this feedback form? I really appreciate it. Okay, so if you guys are interested in weekly classes, right, you can see all the details here. So you just drop me a text via WhatsApp if you're interested.